The tools of nanotechnology allow scientists to build tiny objects with atomic precision. Thanks to a $1 million grant from the National Science Foundation, scientists at Rice University are creating a new microscope where these objects can be built and studied at the same time.
We will have the ability here to, all in a vacuum chamber, build this nanostructure and change the size and shape of this nanostructure while simultaneously measuring the properties of each size and shape. And so you can do a full experiment from beginning to end in one platform, all without ever leaving a vacuum chamber. A scanning electron microscope works basically by firing an electron beam, a focused electron beam, at a sample and scanning it across the sample. And as it scans across the sample, it releases other electrons which are detected, and then we register those detected electrons as brightness. And so we can build up an image of dark and bright by scanning the electron across the sample. One of the things that we're going to incorporate into here is what's called cathodoluminescence. Instead of detecting the electrons that are released, we're detecting the light that's released. We learn where the fields are most intense in that nanoparticle and what the modes of that excitation look like. And by doing that, we learn, we get deeper knowledge about the physics behind the optical excitations, and we also learn things like where are the biggest enhancements of optical fields around those particles, which are useful for a lot of applications. We're going to also have the ability in this instrument to build the nanostructures that we want. We're going to have the ability to do lithography, which is where we expose a pattern, almost like think of exposing an old style photograph. Those patterns that we make are our nanostructures. So we'll have nanomanipulators in the system as well, which will have the ability to do two things. They can move small structures around. So we usually look at particles that are about 100 nanometers large, and we can move those around and manipulate them and even assemble them into larger structures that have even different properties that we can then measure. And we'll also have the ability with these nanomanipulators to move them in and make electrical contacts and do electrical measurements using the nanomanipulator probes.